So remember, you have a quiz tomorrow. It will contain the 4 topics that you've already seen. In addition, it will have 2 different geometry problems, one dealing with segments and one dealing with angles. So 2 new topics on the quiz, one with segments, one with angles. It will look like the classwork. So if you've been doing the classwork, you'll be fine. We're going to go quickly through this next lesson because it's a lot of vocab. So when you come into class, get your dictionary ready because you'll have to put in a lot of definitions. First, adjacent angles. Adjacent angles are angles that share a side. So non-adjacent angles are angles that don't share a side. Adjacent angles share a side. Non-adjacent angles don't share a side. Another definition, complementary. Complementary angles are angles whose measures add to 90 degrees. Supplementary angles are angles that add to 180 degrees. Those terms are very important and things you should keep straight. One student I had in the past thought complementary had 1 p, and in a mirror, a p looks like a 9 or 90. Supplementary has 2 p's, and when you put 2 p's in a mirror, it looks like 2 9s or 2 90s. That's one way to remember it. Complementary, C comes first, 90 comes first. S comes second, 180 comes second. Lots of ways to remember it, but you need to remember. Another very important definition, one that you will see all year, the 2 definitions coming up are linear pair and vertical angles. Linear pairs are angles that are adjacent and the non-shared sides form a line. So in this case, 1 and 2 are a linear pair. You can think of it as line pair, a pair of angles that together make a line. Vertical angles are formed by 2 intersecting lines. They share a vertex but no sides. So look at angle 3 and angle 6. See how those angles are formed by 2 intersecting lines. They share a vertex, but they don't share a side. 5 and 4 are also vertical angles. I am telling you, you will see linear pairs and vertical angles almost every day in a geometry class. You have to know what we mean when we say linear pair and vertical angles. Good? The way we will work with a linear pair or vertical angles, and we will do this more formally in the next chapter, but take a look here at these vertical angles. So here's a line and here's a line. Here's angle 1, 2, 3, and 4. Remember that we talked about a straight line having a measure of 180 degrees. So it should be pretty obvious that angle 1 and angle 2 are supplementary. It should also be pretty obvious that angle 2 and angle 3 are supplementary. If angle 1 and angle 2 add up to 180, and angle 2 and angle 3 add up to 180, what does that mean about 1 and 3? What does that mean about 2 and 4? Hopefully you figured out that angle 1 is congruent to angle 3. And that angle 2 is congruent to angle 4. There's a theorem that we will prove that says vertical angles are congruent. It's called the vertical angle theorem, or VAT. All vertical angles are congruent. Another theorem that we'll study is called the linear pair theorem. And the linear pair theorem says if 2 angles form a linear pair, then those angles are supplementary. Pretty easy to prove, but it's something that we will use a lot. Linear pairs, supplementary, vertical angles, congruent. The last thing I want to draw your attention to is something in the lesson that you should read and make sure you understand, and it's this concept here. There are things that you can conclude from a diagram, and there are things that you cannot conclude. In this diagram here, you can conclude that all the points are on the same plane. You can conclude that A, B, and C are collinear and that B is in between the two. You can conclude that this ray, and this line all intersect at B. You can conclude that angle DBE and angle EBC are adjacent. You can conclude that angle ABC is a straight angle or a line of 180 degrees. You can conclude that E is on the interior of the angle. You cannot conclude that segments are congruent unless it's marked that way. You cannot conclude that an angle is a right angle unless it's marked that way. You cannot conclude that these two angles are congruent unless it's marked that way. The markings help you interpret diagrams. No markings, you cannot conclude this. But Jeremy, it looks like a right angle. I don't care what it looks like. It has to indicate that it's a right angle with this little symbol here. That's it for the video. Be ready to work tomorrow. Lots of geometry. Peace.